सो इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 36 डिस्कस करेंगे, जो क्वेश्चन था कॉम्बिनेशन ऑफ न्यूमेरिकल एनालिसिस एंड थोड़ा बहुत लीनियर अलजेब्रा का। सो क्वेश्चन बोल रहा है कि कंसीडर द लीनियर सिस्टम ax इक्वल टू b वेयर a इक्वल टू aij वेयर aij नॉन जीरो फॉर ऑल I is a matrix with real entries and D is this matrix, then the inverse A is given by this, the inverse B is given by this. So the statement 1 is the approximation of x after one iteration of Jacobi's scheme with initial vector x0 is x1 is equal to this, and there exists an initial vector x0 for which the Jacobic iterative scheme diverges. So which of the following is correct? That is what we need to check. So let's start the solution. First, what I am doing, I'm just writing the Jacobi's iteration formula. We all know that in case of numerical analysis हमें तो formula याद रखना ही होगा. So Jacobi iteration formula is x, we know that x k plus 1, this is equal to j x0 plus d inverse b. सही है ना? So हमें क्या बोल रहा है कि x0 अगर होगा तो x1 whether x1 is this vector or not, where j equal to I minus d inverse a, I minus d inverse a. Okay, so पहले let's calculate I minus d inverse a. I is equal to 1 0 0 0 1 0 0 0 1. This is I minus d inverse a is given by this matrix 1 1 negative 2 3 1 2 1 1 1. Okay, so let's calculate I minus d inverse b. So that is equal to 0 minus 1 2 minus 3 0 negative 2 minus 1 0. So that is our j. Now so x, in place of this, if I put k equal to 0, x1 equal to j x0 plus d inverse b, right? So we have the matrix j. So j is equal to 0 minus 1 2 minus 3 0 negative 2 negative 1 negative 1 0. That is j. x0 is the 1 1 1 1 1 1, and d inverse b is 5 minus 1 minus 1. Sorry, d inverse b is 4 4 1 4 4 1. So if you multiply this, you would get this is equal to 1 minus 5 minus 2 plus 4 4 1. So which is equal to 5 minus 1 minus 1. So let us check our x1 is 5 minus 1 minus 1. So s1 statement is for sure true. So let's discuss about s2. S2 is saying that there exists an initial vector x0 for which Jacobi iterative scheme diverges. So we know that the basic result that Jacobi, let me write down the basic theorem of Jacobi iterative scheme, that Jacobi iteration converges for all initial vector x0 कब, if and only if row of j is less than 1, where row of j is the largest absolute value of the eigenvector of J. Largest absolute value of the eigenvectors of J. सही है ना? तो हमें इस थ्योरम से क्या पता चलता है? जैकोबीज इटरेटिव स्कीम कन्वर्जेस फॉर ऑल x 0 जब इसका जो लार्जेस्ट आइगन वैल्यू का एब्सोल्यूट वैल्यू मतलब आइगन वैल्यू का जो लार्जेस्ट एब्सोल्यूट वैल्यू होगा वो that is less than 1. So now what we have to do, we just need to calculate the eigenvalues of J. Okay, so for the purpose what हमें पहले क्या करना होगा, जो J मैट्रिक्स का कैरेक्टरिस्टिक पॉलिनोमियल है, let's find that J minus xi, that of J minus xi, so that is that of minus x minus 1 2 minus 3 minus lambda minus x minus 2 minus 1 minus 1 minus x. So this the determinant of this matrix. If you break this, you would get this is equal to x cube minus 3x minus 4. Okay, so therefore the characteristic polynomial chx is x cube minus 3x minus 4. Now if we want to calculate the root of this polynomial, that is not an easy task. So but what I am doing, I am just calculating the value of the characteristic polynomial at x equal to 2. So the value of the characteristic polynomial, that is 2 cube minus 3 into 2 minus 4, which is negative 2, and the value of the characteristic polynomial ch at the point 3, which is 3 cube minus this, so that is 14. So हम क्या बोल सकते हैं, c characteristic polynomial at the point 2 is less than 0, where the value of the characteristic polynomial at the point 3 is greater than 0. Then by intermediate value property, I can say there exists a C belongs to 2 3 such that CH at the point C is 0. So हमें एक ऐसा आइगन वैल्यू मिलेगा जिसका वैल्यू 2 से that would be bigger than 2 and lesser than 3. So from that what I can say that जे इसका एक ऐसा आइगन वैल्यू आएगा जिसका वैल्यू 1 से ज्यादा होगा. So अगर if we get an eigen value which is more than 1, so by contrapositive statement or by the converse statement, I can say that there exists an initial vector x0 for which this Jacobi scheme diverges. So both 1 and 2 is true. So thank you everyone.